So there are a couple more corollaries that go along with the cross multiplication theorem. And like I said before, they're not going to make a lot of sense right now, but later on in the chapter, they will make much more sense as we use them. So let's take a look at the first one first here. It says if A, B, C, and D are non-zero. So let's first of all take a look at this, because sometimes we kind of overlook what it means when it says that it is a non-zero number. So it can be any number, A, B, C, and D can be any number but zero. And the reason for that is if let's say that B was equal to 0 and A was equal to 3, I would have 3 divided by 0. You cannot divide something by 0. A lot of times students want to go, well, anything divided by 0 is 0. That's not the case. I mean, stop and think about this for a second. If I have a piece of something and I want to divide it by 2, essentially what I'm saying is I'm going to create 2 piles, and I'm going to cut this thing in half and put half of it into each pile. So that's not a big deal. If I have that same thing and I want to divide it by 1, I'm going to take that one thing and I'm going to put it into one pile. If I want to divide that one thing and divide it by 0, that means I'm going to put that one thing into 0 piles, which is impossible. In fact, if you type 3 divided by 0 or any number divided by 0 on your calculator, it's going to give you this error because you can't divide by 0. That's why it says if A, B, C, and D are non-zero numbers. They can be anything but 0. So let's take a look at this first one. Let's say that I have 2 over 1 is equal to, what am I saying? 2 over 1 is equal to 3 over, or we'll just say 2 over, what am I trying to think here? 2 over 1 is equal to 4 over 2. So we'll take that proportion there. And what this is saying on this first one is if I say 2 and I add it to my denominator, 2 plus 1 over 1 is equal to 4 plus 2 over 2. That's going to give me 3 over 1 is equal to 6 over 2. And you guys can look at that and you can tell that, yeah, that's still true. It's kind of cool. We'll use this corollary a little bit later on, but let's take that same example again. 2 over 1 is equal to 4 over 2. And then I look at the second corollary. This is where we subtract it out. So I say 2 over 2 minus 1 over 1 is equal to 4 minus 2 over 2. So 2 minus 1 is 1 over 1, which is equal to 4 minus 2 is 2 over 2. We see it still holds true. So 2 more corollaries to go with the cross multiplication theorem. That's kind of interesting. And like I said, we'll actually see that show up later on in here. So this is really weird. It's not the same on your paper as it on mine, but it says in the picture, AB over XY is equal to BC over YZ and AC over XZ. It says find the measures of AC and XY. I got to flip over to the next page over here, and here we see it over here. So I know that AB over XY is equal to BC over YZ is equal to AC over XZ. So when we look at this, here it becomes evident that I have the one ratio here that is BC over YZ, right? So BC over YZ, and that is equal to 3 over 9, which I always like to reduce, which is equal to 1 over 3. So now I need to find out what AC is and what XY is. So I'm going to take, for the first one, let's find XY first. I'm going to take this proportion here. So I know that AB is 4 over XY, I don't know, but that's equal to BC over YZ, which is 1/3. So now I can cross multiply this and I get XY is equal to 12. Fairly simple there. So on the second one, I am going to take, to find out AC, I'm going to take this proportion here. So I'm going to say 1/3 is equal to AC, which I don't know what that is, over XZ, which is 15. So now I can cross multiply and say 3 times AC is equal to 15. So divide both sides by 3, and I will get AC is equal to 5.